Hello, computer scientists. We are on page 92 of our directions. We have it over here. I'm not sure how well you can see that, but we are on page 92, activity number 4. We're going to test the speed control with the debug terminal. I do have my basic stamp open here as well, and I also have our Moodle here, which we're going to need here in just a second, but you guys can obviously have that on one of your monitors. All right, but what's going to be very important before just throwing into the code into your basic stamp editor is to really understand the reasoning behind the code that you're putting in. And these directions really explain it very well. So please do me a favor and just don't go down and copy the code and put it in, but really read through this and understand, because when we get out into the field and you guys are testing out and having to maneuver through different obstacles, you're really going to want to understand the logic behind the actual software itself. That yes, I did put in here, but please go ahead and understand what this is all doing. So, all right, you guys. Well, with that, I'm going to scroll back up, if you will, and I have my software loaded into my basic stamp editor. All right, and we have actually used the debug terminal before, but we haven't really put any data into it. So I have my BOBot here, and in the directions it tells you to mark somewhere on the wheel so you can count the revolutions that it's going to spin. Well, I tried a couple different things. I didn't have like a white ink kind of marker, so I put a piece of masking tape here and I colored it red. Now when you turn these servos, please don't rip through them and yank them back and forth. They have plastic gears in them, and well, we know what can happen to plastic, so if you rip it too much you could ruin those gears. So what I'm doing here is I'm trying to set it to the best that I can at the 12 o'clock position, straight up and down there. So I got my little mark there. Again, I'm not sure how well you can see that or not. I'm going to go ahead and turn on my parallax board here, and I need to turn it all the way to number 2, so that way we also turn on the servos. We hear our piezo speaker kind of setting up, and it did move the servo a little bit, so it looks like I do have to move that back to the 12 o'clock position. That's going to be important for us. All right, with that, you guys, I'm over in Moodle, and I'm going to open up a document called Determining Revolutions Per Minute Spreadsheet. And I'm going to bring this over to this location right here on this. And I created this for you guys, and we're going to be putting in some different data, and I gave you the numbers here, everywhere from 650 to 850, and you need to tell me, is that wheel moving counterclockwise or clockwise here? You're going to have to count its revolutions for 6 seconds, and so I 3D printed a couple things here, and whether it's going clockwise with just the C or counterclockwise with the double C, you're going to want to grab the one that you're going to need. And I'll let you know the first one at 650 is going to go counterclockwise, so you're going to want to grab that one there. And I have some numbers, and I'll talk about those numbers here in just a little bit. So again, I do know that my first one is going to go counterclockwise, so let's go ahead and put in that information here. And now we need to figure out its revolutions for 6 seconds. So I need to go ahead and pull up the actual debug terminal, and again, our piezo speaker gives us our pulse, letting you know the batteries are working well, and we have the terminal here. Now it may be hard for you to see. Not sure how well I can blow this up, and it really doesn't do all of its justice even when I blow it up, but I have my insertion key or marker blinking right in this location up here, not down in the blue area, but right here. And the first pulse width I'm going to put in is 650. So I'm going to go to my keyboard and type in 650. All right, I'm going to pick this up in the air, and I am going to start counting its revolutions. All right, after I press enter key. So here we go. I'm going to press the enter key. 1, 2, 3, 4, 5. All right, we were at 5, but we need to figure out where we're at on 5. So I'm going to bring up my little handy dandy 3D printed item, and it's between the 0.25 and the 0.113. So I'm going to try to go between the two. So you may want to go and do a little math and figure out what is halfway between 113 and 0.25. I'm going to probably go 0.1 0.75, if you will, or 0.18, if you will, and go with that. Maybe even 0.2. I might go with 0.2. So there we go. And so I need to do my 5.2. So I'm going to put that into my spreadsheet here at 5.2 revolutions per 6 seconds. Now, obviously, the directions want us to figure out its RPM, standing for revolutions per minute. Well, we're going to have to figure out a formula for that. And so I'm going to want you guys to do a little research on how to create a formula to times our 5.2 time, and that's for 6 seconds, so we need 60 seconds. So we need to times that by 10 to get our 60 seconds, so 5.2 times 10. Now I know you could probably easily do that math in your head and put it in this location, but I do want a formula. So if you have questions about that, do a little research. Figure out how to do a formula on a Google Sheet. There's a lot of data out there for it. So then I want you to come down to 680 and go ahead and put that number into your debug terminal. Again, I'm back here. I'm putting in 680. And I'm going to lift this up. And again, putting this back to the 12 o'clock position. Again, be nice and slow. Don't start cranking those gears around. So get it as close as you can to the 12 o'clock position. 1, 2, 3, 4, 5. Now I can tell that slowed down, and so now if I put my clockwise right there, 5, and it just went a little bit. I'm going to go 5.05, if you will, just a little bit past the 1, so 5.05. All right, and so I'd want to bring my clockwise back down here. That's the position we're going. 5.05 for that. Again, that's an estimate, a little bit after 5. And I'm going to then, again, use my formula to figure out what's my revolutions per minute. Now, you guys would do that for 710, 750, and 790, and 820, and 850. So I'm going to come down to 850 now and test that out. So I'm going to take it back to the center, 12 o'clock. Let me go back up to my debug terminal. And I'm going to put in 850, and when I press enter key, I'm going to start counting. 1, 2, 3, 4, 5, and a little bit past 5. Again, now I'm using the clockwise, so I'm going to grab my C, and it went, again, about 5.113. I'm going to say that's right about there, so 5.113. And I'll put that data in to this column, 5.113. All right, now I was going not counterclockwise, but I was going clockwise here. All right, and again, I need to use my formula to figure out my revolutions per minute. When you guys are done with this document, I do need you to submit that into the Dropbox back into Moodle. But again, make sure that you're kind of understanding why we are doing this. We're kind of testing out the speed of it. If we go down to 790, for example, and press our enter key, make sure I pick this up, you can see that it noticeably slows down. All right, that's going to be valuable information when you guys are out in the field testing these BOBots out to determine what my speed is for different parts of an obstacle course, if you will. All right, you guys, I think that's all I have to say for now. Alexa, tell me a funny joke.
Why did the man become an archaeologist? His career was in ruins.
Why did the man become an archaeologist? Because his career was in ruins. All right, thank you, Alexa. All right, you guys, so have a great day, you guys. And again, if you have any questions, the internet is a great place to find some resources, as well as your neighbors and I. So have a great day.